you'll have to quick do that. Sorry, I'm going to quick do J now. Resubmitting. All right. Forgive me for repeating for those who are here already. But Fusion 360 out the door. Too many people were unable to install it without making major upgrades to their computer. So we're going to switch gears for the rest of this unit, and we're going to look at logic gates again. Now, you might remember we did basic logic gates last semester. We talked about ands, ors, nots, nors, nands, exclusive ors, but that's as far as we took it. We took it very, very basic. It turns out you can go much, much deeper with that than what we've just done. And we're going to use a free online program called Circuitverse, which allows you to create circuits. And I'm going to talk you through the basics of that today. And then we're going to build a few things. But what I wanted you to notice is if you didn't already follow the email that you got last week, Thursday or Friday morning from Circuitverse, it has a link to join. Please join with your school email address. It's completely free. But allow me, then we'll be in one big group. And if you lost that email, you can just use this link that's on the Canvas assignment sheet. Link to join our group. It'll ask you for your email address to put in your school email and then just create a password. Today, I'm going to introduce it to you. We're going to move into half and full adders. Your assignment sheet tonight is actually creating some logic gates, circuits, actually on the program here. Next Tuesday, we'll do flip-flops. You're like, flip-flops? Mr. Clemmer, I have got flip-flops already. I wear them around the house. No. There's logic flip-flops, which are actually one of the more critical ones, and we'll talk about those and perhaps get into a binary counter. And then Thursday and the following Monday, we'll get into some more advanced logic. And you're like, Ms. Clemmer, how come you've got to be determined on these? It depends on how fast and how quickly everybody can pick this up and how many technical problems we run into. So with that, hopefully I've stalled long enough for you to get to Circuitverse and create an account. What does Circuitverse look like? It looks something like, oops, not that, that's me seeing the group members. It looks something like this. And you're like, Ms. Clemmer, it's just a blank screen. Yeah, I'm in circuitverse.org/simulator. Please create your account, your free account first using your school email address. And right now I'm in a project that's called Untitled. I always recommend that you name it. And so I'm going to name this one Logic Gates 01. And there's a few things on it: circuits main, clock time in milliseconds, 500 milliseconds, a half a second, clock enabled. We'll talk about clocks a little bit more. And then, yeah, you can just do that. I'm going to minimize this window, just give me some more space at this point. And then under project, you've got some choices on here. You can save online, save offline, which saves the file actually on your computer. You can open offline, clear project, recover project. I love that. In this case, I'm going to save this one online real quick. And doing that, you'll notice a little icon here. This is called Logic Gates 1. You can put tags on it, description, that's fine. I'm just going to say update project. Done. Not that there's anything in this one yet, but later it will be. I'm going to go back to the simulator. Oh, wait, should I slow down a little bit? Or did you all create your accounts at this point? Can you get to this one? Actually, want to go back to that one. How do I go back to it? Save offline, open offline. I want to go, all right. I am still learning this program as well, I have to admit to everybody, but it's good. So first of all, before I go any further, could you please, just very quickly, I'm going to pull up my video screens. Could you please give me a thumbs up if you're ready to go forward with this, or a thumbs down like, whoa, Ms. Clemmer, I have not created my account. Okay, good. You can use either, you can use your thumbs or you can use the cool little icon thing. Oops, okay, still waiting on it. Okay, I'm stalling for a little bit. Okay, hold tight. So Katie, Kabir, Kier, Thomas, are you almost there? Jay's not there yet. Okay, I'm going to stall for a brief moment. Oh, good. And let me read the chat. Oh, okay. Yep, definitely. So to Daniel, the answer is yes. Let me quick admit. So just sort of checking everybody. Kabir, are you in yet?
I'm making an account right now.
Okay, good. All right. Shoyo, did you get in?
Yeah, I think I'm in there.
Okay, yeah. It's a fairly simple registration process, just your school email and then create a password and pretty much it. Did Oscar get to join yet? Not quite. Give me a quick second here. I'm going to swap back here and fix attendance one last time, I hope. All right, submitted that again. All right. And hold on a quick second again. I should pause the video recording. Oscar, did you make it in? Not yet. Shoot. Joshua, did you get yours account right working? Okay, good. Garrett, you said you were fine. Daniel Hayworth, did you get yours working? Okay, good. Shoyu, are you in?
Yeah.
Okay. Daniel Zhao, are you in? Okay, good. Thomas, are you in? I've forgotten who had up and downs yet. Not yet. Okay.
Yeah, no, I'm in.
Oh, you're in. Okay, good. Kabir is in. Katie, are you in?
Yeah, I just got in.
Okay, good. Kier, are you in?
Yes.
Okay, sweet. Mylan, are you in? Okay, good. Kevin, are you in? Sweet. Jay, I can't remember. Were you thumbs up or thumbs down before? Okay, you're thumbs up. Jungyeon, I
Yeah.
can't see you. Okay. Jungyeon, did you succeed? Oh, he's still getting in. Okay, no worries. Thanks. All right. I think we're mostly there. So let me just show you some of the basics real quick. It's actually a really friendly program. So first of all, just if you go over here to the circuit element area, you'll find a bunch of inputs. Let me quick explain these. These are like the only ones you're interested right now is this one. This one, you can set an input either to a 1 or 0, 1 being true, 0 being false. This is a push button one, where when you push it, it's high, and when you let go, it goes back to low. And this, again, remember, is just ground. And this one, strangely enough, is high. We'll talk about that later. Outputs, there's a lot of them, but my favorite one is this one just shows you the output in binary. It shows you either a 1 or a 0. This one's an RGB LED, like, Ms. Calmer, I remember those. Yep. And this one is just an LED, and we're going to use that one a lot today. Whoops, Oscar is still trying to get in. And then down here, the next one, you'll find gates. And you'll recognize, hey, look, do you remember the shape for these? This is the AND gate, OR gate, NOT gate, exclusive OR, NAND, and NOR. And then this is an exclusive NOR gate. It's a exclusive OR followed by an inverter. Remember, the little circle at the end means it's inverted. So this is like an AND gate with an inverter at the end. And you're like, whoa, Ms. Calmer, I don't remember any of these. Okay, let's go play with these just real quick so you can see again and remember how these work. If you would please go to gates, grab an AND gate and just drag it over. You just can put it anywhere on the screen you'd like. And let's add some inputs to it. And the input you're going to be using, please slow me down or yell at me if I'm going too fast, but go ahead and make this circuit. Grab one of these input ones, the very first one on there, and grab another one here for the other input. And you can put them anywhere you want on the screen, just make it convenient. And then to connect them, you'll see there's a little tiny green dot there, which goes to a green circle when you get there. That means, all right, That's connection. And I'm just going to connect the line over to this one. And so now that connects that input over to the gate. And do the same thing with the other one. You're like, Ms. Clover, this is really intuitive. Yeah, sometimes though getting the lines right, I'm going to stop here and then reconnect over here. Boom. And then we need to see the output of this thing. So I'm going to go to outputs. And now here's the only confusing part. Please, 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 there's a difference between this LED, which you see is a digital LED, glows high when the input is high, and this LED, which is a variable LED, which requires an 8-bit value and then grows with proportional intensity depending on the 8-bit value. Do not choose that one. Life would be bad. But grab this top LED and put it somewhere over here towards the output. And again, we're just going to connect the output there to that. And you're like, Ms. Clover, whoa, so simple. Yep. Hopefully, I'm going to pause for a second to make sure you have this connected. This is an AND gate. Oh, quick side note for those of you who are like, Ms. Clover, when we built these actual circuits, didn't we have to connect power and ground to the circuit itself? The answer is yes. Here we assume, or the circuit is assumed to be powered already, so we don't have to even worry about it. So how do you change the input? You just click on these inputs. Now notice that this became a logical one, positive high voltage, and you'll notice that the wire actually became a lighter green. That indicates that that line, that entire wire now is at a higher value. But notice our LED is still off. But if we click on the bottom one to make it also a 1, notice the LED turns on. And again, if we turn off the top one, it turns off. For an AND gate, both inputs have to be true for the output to be true. And so far you're like, okay, Ms. Clover, so bad, not too bad. If you click on your LED, yeah, let me see. Can we double click on it? No. Okay. I want to expand the properties window real quick here. If you click on the LED right now, it says red. What if you wanted to change your color? Well, you could actually just type in here and make it a blue LED. And we can even add a little name on it. We can say this is the output of our thing, and I'm going to shrink this down again. And now if we run this, make both inputs there, notice we now have a blue LED. You're like, oh, Ms. Clover, that's so trivial. I know, but for those of you who want to change your LEDs to a different color, you can do that. We can also do the same kind of property things with our inputs. If you expand that, we can label this one A. And we can label this one B, which are typically the names that we give those inputs. And now you can vary those inputs and see what the output is. Yes, this also works for any other gates. Let's make one more just for practice before we get into the details of it. If you go over to an exclusive, should we do exclusive or should we do exclusive or exclusive NOR? Let's just do this one. We know that one. Oh, wait. Sorry. There's one other thing I want to show you on this one. Before we go on. Up to this point, we've always had AND gates and OR gates, which had just 2 inputs. There are times when you wish you would have more. So you can actually click on this AND gate, go to its properties, and it'll ask you here bit width, input size, and delay. Actually, one of the things I'm going to do here is I'm going to label this as an AND gate. Hey, look, it's an AND gate. But here, increase the input size to 3. You're like, 3? Yeah, 3. What that means is if you look at your AND gate now, it's bigger than before. It has 3 inputs. And you're like, Ms. Clover, how do you do a 3-input NAND gate? Well, I'm going to add another input. And I guess I should just leave this open. Let's call that one C. And I need to reconnect these all. Sorry, my apologies. Bink. And I'm like, oh, that wire is the wrong length. You can actually click on a wire, and I'm going to hit delete to get rid of that chunk. Actually, I'm not even happy with that one. Delete that one. And now I'm going to draw a new wire from here down to here, and then across to here. And then finally for the bottom one, oops, slide the whole thing down, down, and down. Please, please, please make these circuits as we're doing this, because I really want you to see what happens. So with the 3-input NAND gate or AND gate, what do you think is going to happen in this case? It turns out the only time that this one's true is if all 3 of the inputs are true. If any input is not true, the output is not true. So with the 3-input AND gate, A has to be true, and B has to be true, and C has to be true for that to happen. You're like, Ms. Comer, can I make the AND gate like have 8 inputs? The answer is yes. But it gets to be really painful really quick if you start doing that. One quick thing before we leave this one, you might say, Ms. Comer, could you make this into a push button? Yeah, I'm going to click on this switch. Oops, sorry. Click on that real quick and hit delete. I hope I don't delete the whole thing. Nope, good. I want to show you the push button one real quick. Again, I'm going to label this one A. And then connecting it. Oops, I don't want to move the whole thing. Connecting it, I'm just going to connect it. Ugh. Sometimes it doesn't do what you want to do it. I just want to show you what this does. Now, this one is true only if you click on it. So if I'm holding down my mouse, the output is on. So when I click my mouse, it makes the button true, but the moment you let go of the mouse, it goes back to false. And so buttons are nice, but they don't keep their state. I was debating this one. I'm going to do it. How are your brains this morning? Could you please just give me a quick thumbs up, thumbs down? You're like, or give me a 5-point scale. 1 being, Mr. Clemmer, I just woke up. 5 being, Mr. Clemmer, it's a Friday. I'm good. It's sunny outside. You know, it's good. Where are you at? Ooh, okay. All right. Ooh, sweet. Okay. All right. All right. We're at Tuesday. I don't have anybody at a 1, or at least I didn't see anybody 1. Okay, good. So where I'm going to do that or take you is one step further, something we've never done before. If you go down a little bit here to sequential elements, you're like, sequential elements? Yeah, we'll talk about these a little bit more later. But this one right here, which is showing a little square wave, this is a clock. And if you would drag that out, what do clocks do? Clocks are used in digital circuits. They go between high and low at a regular rate. So for example, your computer, its clock is in the gigahertz range. It's what keeps all your logic gates in sequence. In this case, you might say, Ms. Comer, how do we know how fast a logic gate operates? That was back in the original properties of our whole thing. But yeah, I guess you could label it clock, just so you've got a label. And then if you connect it, you'll discover that something interesting happens. In this case, the clock changes values every 500 milliseconds. You're like, Ms. Comer, it's sort of like Arduino. Yeah. It's sort of like that again. But in this case, the clock is a timing element that keeps everything in sequence. In this case, every time the clock goes high, the output goes high. Yeah, again, if I change one of these, nothing much is going to happen. But a clock is a very useful thing, and we're going to be using it a lot in the next couple of days to keep all of our logic gates working together. But clocks are fun. Yes, you can change the rate at which the clock runs. I haven't tried it yet. It should actually work. Let me go to 1000 and see what happens. 1001, 1002. Yeah, and you can change the clock rate fairly easily. You can also use this one. But yeah, it's really fun. All right, you're like, got it, Mr. Clemmer. All right, so now let's take a look at this one. Can I slide this over somewhere? I'm gonna try to move this over here somewhere just so it's out of the way. Actually, maybe over here somewhere. And let me talk about what your homework is tonight. Tonight is very, very simple. And let me switch to PowerPoint just real quick so you can sort of see it. You have a worksheet tonight, and you're going to be building some basic circuits. You might remember this worksheet from way back when we just did it in paper. But this time, and I remember today is actually just introducing yourself to Circuitverse. And so it's not meant very, very hard. What we need to do here is create a circuit that represents this. And you're like, what Whoa, Ms. Plummer, I've forgotten all this. Yeah, let me quick remind you of what it is. First of all, these symbols. The and symbol, if you look over here, is for or, which is a little bit backwards if you remember. So what I need here is not A, remember the little line over it means not A, or B. And then this symbol here, if you look over at the logic gates, is the symbol for an AND gate. So I need to create not A or B and not B and A. And first of all, I'd like you to do is draw it out with a circuit here, or I'm going to draw it out, and then we'll actually create it in Circuitverse. So first of all, I've got an AND gate at the end. If you remember the symbol for an AND gate, or you can look over the side there, is just one of these. So here's my AND gate. So this is my output. And now my choices are, I need to do, these are OR gates in front of these. So I need an OR gate, or two OR gates. One of these OR gates is going to feed into the AND gate. And the first one needs to be not A. Here's my, I'm going to put my little, I'm just going to mark these as buttons right now. Here's A. I need to go not A into the first OR gate. Remember, the NOT gate looks like this. And then I need to do OR B. And so that simply goes in like that. All right, so that takes care of this first part. And I got the AND already there. And then I need to do the other part here. And I'm just going to quick draw in a different color just because it gets a little bit confusing. It'll be much prettier in Circuitverse. For my other OR gate, this part right here, which again is an OR, that goes back to my AND. This one needs to be not B. So I'm going to invert B. I'm assuming this is connected here. And A. And so for A, a little hopscotch and down and like that. So this is the circuit I need to build in Circuitverse. So what I'd like you to do is in this worksheet, or sorry, in Circuitverse, this is your homework for tonight, is actually create the circuit. So if you would please, I'm going to go back over to Circuitverse. And you can do this in any order, but I'm going to put my gates out first. I need an AND gate. And I need two OR gates. And unfortunately, I can't quite get them close enough to this one. I'm just going to have to bend a little bit. But I'm going to put them pretty close together so we don't get too much problem. And then switch back over again. I need a NOT gate on A. I'm going to put that really close there. And a NOT on B. Put that down really close there. And then add your inputs. And hopefully you aren't going to find this too painful. And I'm going to leave a little space here. This is going to be my A. I'm going to label on it. And another one over here, and this is going to be B. That's interesting. All right. So connecting all the dots. This one is going to connect there, and then there, and then this connects to there. And then A also connects down. I'm going to bring it over this way. And then down. And this gets a little bit messy, I have to admit. I wish we could, if you remember when we used, what program did we use? We could draw wires in different colors. Oh, I guess, I don't know if I had you use it or not. But yeah, it's a little messy, but hopefully not too bad. Down. And then from there over to there. And this over to there. And then I also need to go B over to there. Now, when you cross wires, unless it's got a dot, it doesn't mean that it's connected. So don't worry, this actually works. And then from here, I need to go, I'm gonna move that down. Just, I guess there's no way to work. And over to there, and over to here. And then this one down and over to here. And then add an output. You know what, maybe let's just go ahead and use this one, it's easy. So instead of the LED, under outputs, there's a general X red one. And I'm going to label this one out. And now this should actually generate the truth table that I wanted. And so what you're going to do with this one is just create the circuits in the worksheet. The worksheet, just so you can sort of see it real quick, is not that long. The worksheet, whenever it decides to show up, looks like this. First page is just all of this, the truth tables again, if you've forgotten them. And then here's the construction part. We just did C. You have A, B, and D to do on this one. And then the second part of this one is, remember, this time now I want you to create circuits for the Boolean expressions shown below here. And I want to do one of these together with you as well. What would be a challenging one? Let's do D. The horn of a car must sound when you press the horn button, or if the security alarm is activated, or if you leave the headlights on and leave your key in the ignition. That one's probably one of the longer ones, but there's three things that could sound the horn. That, or that, or that. And so how do you construct this one? Sorry, I should put a little, I'm highlighting this one. This is the one we're going to create. And so if I go back to circuit verse, I've got three things that if any of these, if A or B or C is true, the horn goes on. So what I'm going to need here is an OR gate, but I'm going to need an OR gate that has three inputs. So again, under properties over here, drag the OR gate over and give it three inputs. And our output, I'm just going to drag it over here. I probably should give myself some more space. What's the output called? It's the horn. And what will set off the horn? The answer is, I'm going back to inputs. Put an input over here. One of the things I could set it off is you hit the horn button. Now my text is kind of hidden, but that's all right. Or the other thing it could set it off, I don't know how close I want to put these. Let's keep them separate. Or it could be that the security alarm went off. So I'll label this one security. Or, and then here's where it gets a little confusing. Let me go back to that question so you can see it. Like, Ms. Calmer, I'm getting dizzy. I know, I'm sorry, switching screens too much. Or if you leave the headlights on and you leave your keys in the ignition. And so the last one is a little bit more interesting. We need an AND gate. And so for the last situation, this one turns on if two conditions are met. Back to our inputs. So keys, let me say, just say keys in, ignition. I don't want to write ignition on there. Or sorry, and lights are on. So if both of these conditions are true, that'll do that. And so now if you check this real quick, yeah, the horn's on right now. If you press the horn button, it goes on. If security goes on, it turns on the horn. If you leave your keys in ignition, not a big deal. But if you leave your keys in ignition and your lights are on, it sets off the horn. And so this is the logic gate then for that particular situation. So you can sort of see this one. And the nice thing is when you're done with this, you can simply save it. You can pan on this thing. It goes on forever. So you can put all of your circuits in here. It just gets a little crowded. And the one thing I haven't figured out yet is how to simply put a label by your circuit. There's got to be a way to do it. Is it under annotation? Arrow, it's just plain, oh, text. Maybe that's it. Yep. All right. So the text I want to put there, this is 2D. Nice. Okay. As you can see, as I said, I have not played with this much yet. I am still learning it. So this was question 2D. And so you can label by each one of your circuits what they are. Please label your inputs and outputs so it makes it a little bit easier. Like A, B, or out. For this one, I guess I should put text on it as well. This one was one, oh good grief, what one was it in the worksheet? Hold on a second, I gotta look. That was 1C. Okay, so 1C was that one. So you can label these as you're doing them to sort of work your way through it. And so so in a lot of ways, this today is just a really quick introduction, not meant to be very difficult at all. We're actually doing circuits that we've done before last semester, but this time you're going to be building them in Circuitverse using actual circuits, which is actually kind of fun. If you want to, you can definitely explore around on this thing. It's actually got a lot of options. When we get in here, some of the sequential elements are actually kind of fun. You can actually have a ASCII teletype display. You can have a keyboard. You can have a ROM, a read-only memory. You can have some electrically erasable programmable read-only memory. You can have some random access memory, RAM, and a bunch of other things as well. It's a lot of fun. I don't know, what's under miscellaneous? The cube. Oh, what in the world? Okay. Ooh, two's complement. And okay, all right, that's good. All right, so there's some other things in here that'll be fun as well. Your homework for tonight, and I'm just debating if I want to do a little bit of notes with you. Whoops, I hit the wrong one, sorry. Your homework for tonight is to create those logic circuits on that worksheet. There's a link to the worksheet here. And I wanted to introduce you real quick to, we've already done the basic input, let's just say and logic gates. The other thing I wanted to quickly do with you before I leave today is do a full and a half adder with you, or at least talk about it, what they are. And so let me hop back over to the PowerPoint, and then I promise we'll end early and let you get some work done. Oh wait, okay, I have that one on here already. A half adder. And we talked about this briefly when we're talking about logic gates, but let me just talk about binary math a little bit. So again, just a quick reminder on this one. It's been a long time since we've seen this. Binary numbering system. This is 0. This is, sorry, I should explain real quick. This is the 2's place. This is the, oh, Oscar made it again. This is the 1's place. The next one over here would be the 4's place, but and the next one over would be the 8's place. Remember that? I'm just going to do 2-bit for now. So for example, 0, 0 is equal to 0 base 10. 0, 1 is equal to 1 base 10. 1, 0 is equal to 2 base 10. And 1, 1 is equal to 3 base 10. My apologies for my really horrible handwriting here. What does a half adder do? It basically takes that. So it converts it if you're adding 2 bits. So each one of these A and B can either be 1 or 0. If you put in 0, 0, if you're adding 2 zeros, the output should be 0, which means this should be 0 and this should be 0. But if you put, for example, in either a 1 for this and a 0 for this, what's the addition of 1 and 0 in binary? Well, it's 1, which is written 0, 1. So it should be just 1 here. And this is the sum, and then this is the carry digit. You're like, what's a carry digit? Well, think, for example, if you ever added in decimal 9 plus 4, you would get 3, plus you'd have to carry the 1. This is the carry part. I guess I should make like 9 plus 14. And that would give you 23 if you added those together. The 1 here is the carry bit because when you add these two numbers, it goes over what can be stored in one digit. And so it moves on to the next one. In this case, there is 1 plus 0 just gives you that. There is no carry digit. The same thing would be true if you put in 0 and 1. The output would be exactly the same. But where it gets interesting is this. If you put in 1 for A and 1 for B, what's the sum of that? Well, the answer is 2. But how do you express that in binary? Well, the answer is the sum of those two, 1 and 1 is 2, which should just show up like this. So the sum would be, poor Oscar keeps getting kicked out. The sum should be 0. That's what goes in this spot right here. Actually, let me write this out. So this is binary addition. What's the sum of these two? The answer is, believe it or not, the sum of those two is 0. And then we've got to carry it over here to the next digit or next spot. And so it gives you 1, 0 in binary. And so the carry digit here has to be 1 if you send in those two. How do we actually make this work then? Well, this has to be 1 if and only if one of the inputs is true and the other one's false. So that's a perfect case for an exclusive OR. That's the only time this one output is true. So an exclusive OR here is a perfect choice. And then what about the carry bit? Well, the carry bit only comes into play if both of the inputs are 1s. And so we need this one to be true, the carry bit to be true, if and only if both of the inputs are true. And so this is considered to be a half adder. Half adder because it adds 2 bits together at any given time. And so it's literally doing the addition here where this part right here is the sum, and this is the carry digit. And these are our 2 inputs. And the biggest it can ever be is 1, 1, where both A and B are 1. So yeah, it's pretty simple. The circuit I want you to build tonight, it's actually the question number 3 in the worksheet, is the full adder. And I'm just going to show it to you real briefly. The full adder looks like this. And you're like, whoa, what's going on, Ms. Clemmer? What's different? We're going to add a carry in pin. And again, it has the sum and a carry out part. And I want you, and you're like, Ms. Clemmer, quick, I'm going to leave that circuit there. That's the full adder. And you're like, Ms. Clemmer, wait, you didn't show us the circuit long enough. I know I didn't. I want you to quickly find it online and then create it in the circuit out of logic gates. That's the last question in the worksheet. How long should the worksheet take you? The answer is it should only take you about, I'm hoping, especially if you've been cruising on it while I've been talking, it literally should only take you about 20 minutes to make all the circuits. And you're like, Ms. Clemmer, no, it won't. Well, you can actually do some copy pasting in here as well, which makes your life a lot easier, especially when you've got a lot of buttons. But after you get the hang of this one, it's actually very quick to make them. Please, 2 quick things on this one. When you're making this worksheet, please call it Logic Gates 01. And please, please, please label your circuits so when I grade it, I can find them. That is the only pieces on this one that I want you to work on. So if you look at the assignment sheet real quick, I'm going back one last time. Your homework tonight, if you haven't already done so, Oscar, I know you just joined us. Join our group on Circuitverse just so it makes it easier for me to grade your homework. If not, I'm going to have you submit your files to me offline and into a Dropbox. And then just follow the worksheet. There's 4 where you've got to create them from the Boolean logic. And then there's 5 where you're actually making it based on the word sentence like we did with the car horn. We've done one of each of those already. so you at least can see it already. And then you've got to create a full adder, which is just, you're gonna have to look it up real quick online. The link to the PowerPoint I shared you is here, which means you're going to see the circuit full adder on the last slide of this one. So if you're really stuck, but literally if you just put in full adder into Google and just look for an image, it'll show you it just takes 4 gates to make a full adder. But that is your only homework. With that, I promise you I wouldn't take too long today. I'm going to stop my share. Are there any questions or any problems that you've run into? Tonight's homework, really basic. You've seen half adders before. The only new thing you're seeing today are full adders. You know, like Ms. Klammer, are we moving into more things? Yeah, so next time we'll get into flip-flops, which are an entirely new section that we haven't seen before. And we may build some counters, and then we'll get into some more advanced logic after that. Just using some logic gates. Just 4 days in Circuitverse probably, but at least this one doesn't require any software installation. It's all online, and as far as I know, you don't need a virtual private network to be able to get to Circuitverse. So hopefully all of you can work on it without any problems, no matter what computer you're using. So again, yeah. Oscar, I thanked you in advance. Well, did you make it in? Yes, you made it in. Forgive me, I was planning on this one, and then when you gave me the ideas of LSpice, which I have used before, and the other ones, I went with this one because it was very lightweight and ran in the browser. It didn't cost anything, and it seems to do mostly what we wanted to do. It doesn't have all the features, but it's a nice one. With that, I'm going to stop my recording if I can actually find that. Let me stop